Hello. In this video, we are going to take a look at some properties of convergent and divergent series that we know, and look at one more example of using the geometric series tests. So, the properties of convergent series, suppose we have a series that converges and we have a real number, then I can multiply by that real number. And that is just the same as passing it through the series, and this still converges. Because if a series is converging, it means it's going to a finite number. And if I multiply by a real number times real number is a real number. If I have a series that diverges and I multiply by C, that still diverges. I can multiply it on the inside as well. So I can't multiply by a real number and make things suddenly nice. That real number will either keep it converging or diverging. Suppose I have two series that both converge. Then if I add them together, that would be the same as taking one series plus or minus the other series. So I can split them up, and this still converges. Because again, we'd have real number plus real number, which is a real number. However, if one of them diverges and one of them converges, adding them together or subtracting them will still diverge. Well, not still, because B sub k converged. It will diverge. Now, notice before we get into 5, there's not a case of one series diverging plus another series diverging, still being divergent, because there are actually counterexamples to that. For example, if I take the series -1 to the k and the other series -1 to the k plus 1, for geometric series reasons, these both diverge. However, because this series is -1 plus 1 plus -1 plus 1, and so on, and this one flips those signs. This is 1 plus -1 plus 1 plus -1. When we add them together term by term, we actually end up with 0 plus 0 plus 0. So we don't have the divergence case of both of them diverging, because they might actually contradict each other and result in something converging. So we don't have a divergence of adding two things that are diverging together, but we have, if they both converge, it continues to converge, and if one of them diverges, it'll definitely diverge. And then the last property is if m is a positive integer, then it doesn't matter if I start my lower bound at 1 or if I start my lower bound at m. Either both series converge or both diverge. And we actually use this property in the back a lot, because there's going to be several tests we're going to do that are, we need the series to be positive, or we need the series to be decreasing. And we're going to say it needs to be positive for the whole thing, but ultimately it just needs to be positive eventually. Because if once it is positive onward converges, then I can add on these little terms back here from K to M and still get something converging. Or if something's ultimately diverging at the end, adding on extra terms is not going to make it suddenly converge. So either both of these will converge or both of them will diverge. And so our last example is taking these properties. In particular, we're taking that third property where we can add and subtract. So this series, hopefully, both series will converge, or one will converge and one will diverge. I can split into the series 4 times 3/8 to the k plus 1 minus the series k equals 1 to infinity of 2 times 4/5 to the k minus 1. Now, this first series converges by GST with the absolute value of R equal to 3/8, which is less than 1. So that one converges. The second one converges by AST, by GST, because the absolute value of R equals 4/5, which is less than 1. So both of these converge, meaning this whole big thing converges. Now, because they're both geometric series, we can figure out what this converges to. And so finding A, when we find A here, we can plug in 1 to get 4 times 3/8 squared, which is 4 times 9/64, or 16 times 9 over, 9/16. So there is A for the first series, meaning we have A 9/16 equals 9/16 over 1 minus R, which is 3/8. So that is what the first series will add out to. The second one, R, is 4/5. A, when I plug in 1 minus 1 is 0, A is just 2. So minus 2 over 1 minus 4/5. Simplifying these down, we get 9/16 over 5/8 minus 2 over 1/5. 1 minus 4/5 is 1/5. So this first fraction will simplify down to being 9/10. And the second one simplifies down to being -10, well, to being 10, and we're subtracting them. So we have 9/10 minus 10, which works out to be, let's do 9 over 10 minus 100 over 10, which is -91 tenths. So we actually know it converges to negative 91/10. And there is our last example of using the properties of convergent series as well as the geometric series test. In the next sections, we will get into more tests for how to tell if a series converges or diverges.